So we'll carry on with the examples of macromolecules like polymer chemistry, additional polymers. And you see only alkene derivatives, ethene derivatives, just like the polystyrene was an ethene derivative where only one hydrogen was replaced. Our polyvinyl chloride is ethene derivative, one of the hydrogen is replaced. If 4 of the hydrogens are replaced by these fluorine atoms, it is tetrafluoroethene. And when it enter into the polymer converter, huge number, unlimited, infinite. You force them into the polymer converter, the machine has high pressure, temperature, catalyst inbuilt. The outcome is polytetrafluoroethene, and in the market it is named as Teflon. And Teflon is basically non-stick pans or other non-stick cooking utensils. They give us a break, you see, that things are not burnt, okay. May have disadvantages because long use may break them up and some of them enter into the food stuff and cancer stuff. But if you replace them properly after a certain time, then or wash them properly, never scratch their coating, then they stay long. Remember, Teflon is also used as weather shield paints, okay. So two main uses: weather shield paints, resistant to weather, coarse weather, and also they are used as non-stick. It means their property is what? They can resist high temperature. Just like polyvinyl chloride's property is what? Resist current, electricity. Okay, they're all insulator. Flexibility is, that's why polyvinyl chloride is used as a wire insulation. Teflon, non-stick material. Packing material was what? The best packing material was polystyrene. So non-stick pans, weather shield. And again I said, if they ask you to draw part of polymer, you can show 2 repeat units. Look at 1 repeat unit and then a repeat unit. It is additional polymerization. The word additional means monomers join to make polymer. There is no waste material. Net mass of monomer is same as net mass of polymer. Okay. Plastics have their various uses, and variety of plastics are devised. It depends on the kind of the monomer you use. Monomer, single unit somebody actually devised in his research. Then the variety of polymer is there in the market with its own peculiar uses. So we have plenty of stuffs and material to wear and plenty of, you see, things used inside the car interior like the car dashboard, and also plenty of glass and other things we use, drinking stuff. We have something, variety of cups and colored things. They are all basically varieties of polymers, okay, but they are derivatives of alkenes because they have the double bond and the double bond opens up. Look at the continuity shown. I mean, it's a never-ending structure, a macromolecule. And always if a chunk is given, you can count the number of atoms, the head count, and then you can simplify to find what? Empirical formula. Okay, so this is simply ethene derivatives. But if it is propene, then we'll have polypropene, and if it is butene, we'll have polybutene. But sometimes it is difficult to write its polymer equation because they give it like this, C3H6, and you know that it may be like this or it may be like this. So how to write actually basically the polymer equation for this? The best thing is focus on the double bond. You know that double bond opens up. Focus on the double bond and bring it to ethene style. It is propene, bring it to ethene style. Now 2 hydrogen attached here. Here 1 hydrogen attached and 1 CH3 group attached. So way of writing actually makes things easier to write a polymer equation. I have written this propene. If I write it like this or this, basically it becomes difficult to write, rather almost impossible to write a polymer equation, to represent a polymer equation. But if you focus here and just bring it to ethene style, this is propene, C3H6, you can notice, put N here, huge number, unlimited, inside the polymer converter. And as it is translated out, you want to write the polymer repeat unit, it is the polymer repeat unit, but it look like ethene, polythene. It's not one hydrogen here, one here, one here, but this is not hydrogen, this is the CH3 group being pushed aside. So the polymer equation can be written. Now this is propene, remember. A wonderful kind of plastic, much better than ethene derivatives, propene. This is polypropene. As the molecule gets bigger, the strength of the plastic grows because intermolecular forces are much. So polypropene is used in better quality chairs and stuff and other things that is made, the car dashboard and stuff. You can also write the chunk for this and the part of the polymer. Look at, if I show 2 repeat units, then continuity should be there. Should not be a mistake there. Look at the continuous shown. But this is monomer. And put a CH3 there, then one gap, then CH3 there. And it shows what? Part of polymer. Sometimes part of polymer is given, they ask you to write monomer. Monomer means starting molecule. Then notice a repeat unit, isolate a repeat unit and bring it on like this. Put the double bond, check the carbon's valency. This is original thing, the propene from where this polypropene is being made. So propene turns to what? Polypropene. Had it been butene, then it means C3. No, it is C4, H6. No, it is H8. And you write, you will find out either the double bond is here or the double bond can be there. Things become tough. Bring it to the ethene style. Okay, mean these 2 carbon atoms joined together will make what? C2H5. And here it will be C2H5. Same there. C2H5. Now this is not butene basically. This is butene. This one is butene monomer. But this is polybutene, and that is polybutene repeat unit. Even it is pentene, you focus on the double bond and attach, C2H5 will change to C3H7 in that case. So you may be asked to write down a polymer equation for a propene molecule or a chunk for a propene molecule. Never get weary. Think, I need to focus on the double bond. And the rest of the things, 3 should be hydrogen atom. 4th one, combine all those carbon chain and bring them there. Propene to polypropene, butene to polybutene, pentene to polypentene. Even sometime you can be given a mixture in your assignment, mixture of ethene and propene. Don't worry, just join them together as you are doing for this. Okay, and never care for any sequence because individually each one is a potential monomer. So it means plastics, the polymers, the additional polymers, basically is a process monomers join to make polymer with the unique properties depending on the kind of the monomer you have chosen. Okay, as the molecular size gets bigger, their strength grows, their density grows. Okay, their melting boiling point grows. They become resistant to heat, like a car dashboard. You take it out of a junkyard, you will find the strength there, still shiny. Good one. Reason? Because that is high quality plastic, like some of the plastic furniture may contain polypropene or polybutene derivatives basically. Butene or propene derivatives, the polybutene or polypropene or a polypentene. That's why they give a lifelong basically warranty for that sometimes. Strength it is. But never forget how to write the polymer equation. Focus on the double bond and rest of the carbon chain join it to one. Okay. Repeat these lessons, see them, practice them. This is additional polymerization. Plastics, every kind of plastic has its own uses, but general environmental hazards are same. They are non-biodegradable. They may accumulate as trash. If you burn them, they'll release poisonous gases to the atmosphere. Safe use if they ask, find landfill sites or burn them into the incinerators or recycle them properly. Never release anything to the air, never spoil the environment. Okay, be careful then.